All right, so we have compound inequalities today. Which again, no different mathematically. It's a little bit different conceptually what we're doing here. So like if we look at our example, like we have 8 is less than 3y minus 7 is less than 23. Which means our answer, instead of just being like the ones we did the past 2 days, there'd be some number, some key number, and it would either be less than or greater than that. So this would be what your final graph looked like, right? It just goes on forever in one direction. When we start talking about these compound inequalities, it really narrows down, or actually in some cases expands what the possible answer could be. But that'll make more sense if we actually see what happens here. So 2 ways we could solve this. I'm going to show you the way I don't really like first, and then we'll go to another way. So we can actually take this and split it into 2 separate inequalities. So I could say 8 is less than 3y minus 7. And then we can also say that 3y minus 7 is less than or equal to 23. And then we can just solve both of those individually. So over here we could do plus 7 to both sides. We get 15 is less than 3y. And then we can divide both sides by 3, which gives us, cancel these out here. So 5 is less than y, or to rewrite it, y is greater than 5. Okay, so this is part of our answer. And then on the other side, we do the same math, so it's going to be plus 7 to the left and right. So that's 3y, and then over here is 30. And then we can divide both sides by 3 again. Ooh, I should remember to bring down my symbol as well. So we get y is less than or equal to 10. Okay? So that's one way to do it. So we know our answer's got to be greater than 5 and less than or equal to 10. And that's nice, but that's a little bit, it's kind of a lot of writing. So the other way we could do this is if we leave it the way it's written and we just solve both sides at the same time. So I could say, I know I want to get rid of this minus 7, so I'm going to do plus 7. I really wanted that to be red. Plus, you see red selected up here. Select it again. There it is. Okay. So I want to get rid of this plus 7. So I want to get rid of it from both sides over here. So I'm going to do plus 7 on the left, plus 7 on the right, plus 7 in the middle. So that gives us 15 less than 3y less than or equal to 30. Okay? And then I want to get rid of this times 3. So same thing. I'm going to do divide by 3 on the left, on the right, and in the center. So this one will cancel out. 15 divided by 3 is 5. Y in the middle, y less than. And then we have 10 over here. And if you notice, I mean, it's the same answers that we got on the left and right, but now it's all in this one statement. And when you look at your answer choices, that's how our answers are going to look. So this, the first way we did it, that'll get you the right answer. It takes a little bit more time, but it might be easier to see for you. But if you have a pretty good grasp on it, this is going to save you some time. Okay, before we move on, and we're not going to see this till tomorrow, but I feel like it's not going to hurt us to see what this looks like. So don't write this part down yet, because I'm going to erase some of it. So now we have 2 key numbers. We have 5 and we have 10. Okay? And I know x is going to be greater than 5, so it's going to be an open circle. And it's greater than, so it's pointing to the right. But then we also know that y is less than or equal to 10. So it's a closed circle pointing to the right. But given the way this is written, it says it's got to be between those two numbers. So the arrows don't extend forever. They only extend till they get to that other point. So instead of drawing it like this, erase all this. Now you can start writing. What we're going to do is we start off, we put our two key points, so closed circle and open circle, and then just say our answer is everything between, we just connect those two. So if instead of extending forever, when your statement looks like this, they're going to point at each other. Okay, there you go. There's your and statements. So all the ones on the left-hand side are going to look like that. Again, we'll look more at the graphs tomorrow. All you need to know for now is how to get X or Y by itself. Okay, the other side, this is a little bit more straightforward. The or statements. This one you have to solve two separate problems because that's what is given to you. So all we do is we solve like we did on the very first day. So if we want to get X by itself, we do -5 to both sides. I really wanted red. This cancels, -2x greater than 7 minus 5 is 2. Then we want to get X by itself, so we divide by -2. Remember, the rules still apply. We didn't see it on this example, but if this was negative, we would have flipped both of these symbols. I would have changed both symbols here. Okay? But over here, since we divided by -2, instead of X is greater than, now we have X is less than. 2 divided by -2 is -1. Okay? And then we can split this off here. Then we solve this other equation. So to get X by itself, we do -3 to both sides. That cancels. So 9x greater than or equal to 81. We divide both sides by 9. So this cancels. We have X. We didn't divide by negative, so that symbol stays the same. Greater than or equal to 81 divided by 9 is 9. And there are answers. So we would say, so you can see how they look here, is since it's or in the middle, it just means only one of these has to be true. And I know you kind of missed out. You didn't take geometry, so you didn't get the whole logic lesson about and or. But or means only one has to be true. So if we were to graph this, again, we have two key points, so -1 and 9. And make sure when you're graphing these, make sure your number line is ordered correctly. Smaller numbers to the left, bigger numbers to the right. They don't need to be this far spaced out. I don't even know why I did that. So less than 1, so open circle pointed to the left, or greater than or equal to 9, so filled in circle pointed to the right. So instead of two sides coming together, when we have or statements, we have two answers and they're going apart from each other. So our answer can really be anything in the world except for everything between -1 and numbers less than 9. Okay? So or the graphs are going apart, and statements, the graph is going together. Okay, there's some special cases we might run into, but not today. Today is nice and straightforward. If you have any questions, let me know.